Hi everyone. Short introduction. Congility is a software division of Mecon Limited. We are an RWS partner focused on delivery for manufacturing, service and regulatory applications. In this presentation, we're going to talk about improving the efficiency of technicians doing manufacturing, service or repair tasks in the factory or field. There are three key elements the technician needs in order to perform tasks efficiently and safely. Retrieval, so how does the technician get the correct task content? What level of interaction do they need to have with the task content? And lastly, what is the situation or environment, i.e. where is the work to be done? If we start with content retrieval, let's consider first how the technician gets the correct set of instructions for the task in the easiest way possible. Typically, organizations that rely on technicians to maintain products will have many different variants and subsystems, which means the content required for one scenario is different to another. Each subsystem typically has a separate task associated with it. This results in the organization having many thousands of tasks. Technicians need an efficient way to get the correct task content. Excuse me, I dumped a slide there. A content delivery platform will have a search capability. So technicians can search for all of the information they need. They can use filtering techniques to drill down the content library to find the content they need, perhaps filtering by product, sub-assembly, etc. However, this can be time-consuming, or searching in this way can be time-consuming and error-prone. How do we achieve the technician being given the correct task content automatically without the need to search for it? Organizations typically use a product lifecycle management system, a PLM system, and make use of bills of materials and bills of process data within it to manage product configurations. Combining PLM data with CRM and MMS, that's maintenance management system data, can provide the information required to ensure the technician is automatically given the correct content. The CRM system knows what products the customer has, and the PLM system knows about the configuration of that product. The key to getting the correct content automatically is ensuring a consistent use of metadata across these systems. The metadata provides the join between the systems. So in this example, product equals a spaceship, the task equals upgrade, shape equals cone, and color equals red. Knowledge of the technician is also an important factor. Do they have the necessary level of competence to undertake the task? Do they have the appropriate permits? Does the task require more than one technician? For example, the cone upgrade requires a competence level greater than 4, and the technician is a level 5. So in this case, they're good to go. Just when you thought getting the correct task content was hard enough, this is only part of the information a technician needs. There are all sorts of related content they also might need to access before they undertake the task. Technicians need to be kept up to date with important information which can affect the task. This is often created by other parts of the business, such as the customer support department. If an issue arises with a product, it might be reported by one technician, but it needs to be quickly conveyed to others. This might be in the form of bulletins or technical alerts that are generally time critical. Therefore, technicians need to be alerted before or while performing the task, and the bulletin or alert removed when it is no longer valid. Metadata is used here too. The metadata determines which tasks an alert or bulletin relates to. In some cases, the alert might be important enough to justify the technician acknowledging it before they can carry out the task. This may be because the task is dangerous and requires additional information, for example, a risk assessment or lifting plan, or perhaps simply a change in a cleaning method. Interaction. In addition to acknowledging content, other types of interaction may be required, such as adding notes or providing feedback or comments that can be used by the wider organization. Let's see some examples of how this might look. This slide shows a technician adding a comment. These comments or notes can be shared with other technicians and the content authors to improve the content. Technicians may want to create new content based on their experience of directly doing the task. For example, to help remove errors in the content. This example is creating a field technical alert, an FTA. It can relate to one or more products, particular subsystem, particular geographic region, priority, etc. And drop-down lists for creating the field technical alert attributes are driven by the DITA subject scheme or taxonomy. The contributions, feedback, technical alerts, etc., created by technicians within the content delivery environment can be moderated by different teams using different workflows. For the example on the left, you can see the different types of feedback. eLibrary feedback is for the content authors. All other types of feedback or contributions are moderated by the customer support department. The technician's experience and insight when actually doing the task can potentially improve the task, making it more efficient and less error prone. This is especially good for rapidly improving new content. Our customer Siemens say that new task content is usually about 90% correct, and they rely on and incentivize the technicians doing the task to correct and improve it. For business intelligence, managers may need to see reports of how the content is used, what is viewed, what is opened and downloaded for offline use, etc. For due diligence, managers may want to see when important aspects of the content were acknowledged. For example, reasons for content changes and change history. Asking technicians to acknowledge content changes can ensure that those who are familiar with a task and ordinarily may not read the task instructions are forced to acknowledge the task has changed. Also, risk assessments, permits to work, technical alerts or bulletins, and warnings, etc., may need to be acknowledged. Acknowledgements can be automatically added to the content based on content metadata or attributes and can be configured to appear or reappear after a certain period of time. Acknowledgements are tracked and reports can be configured. This can be important for health and safety and due diligence purposes. So we've looked at how content can be retrieved by technicians. We've also looked at how they can interact with the content to improve it and provide necessary feedback. What we're going to look at now is the situation or location, i.e. where the tasks are going to be performed. So rail or transport might be in a depot, trackside or roadside, could be in a tunnel with no or partial internet connection. General manufacturing is mostly in a factory environment. Semiconductor might be in a dust-free fabrication plant where there are very strict rules about who and what devices are allowed into the area. For example, technicians will typically have dedicated devices that can be used in the environment and cannot be taken outside. and the site may be internet locked down. Construction, agricultural engineering, etc. may need to support customers outside in remote locations with partial or no internet connection. Or perhaps organizations simply need to ensure continued access to content in the event of IT failures. Wherever a technician is performing a task, they need to use the most appropriate device to access the content. That could be a small screen phone, a tablet, laptop, toughbook, or an augmented or mixed reality type wearable device. And some of the important considerations we have are: if you're offline in a remote location, neither browser or offline support or PDF can be relied upon to ensure the technician always has the most up-to-date content, and that any interaction they have with the content can be captured. The technician needs to be able to take content offline while ensuring the content is always kept up to date, and any interaction with the content, so for example notes, feedback and acknowledgements, the types of things we were looking at previously, are captured through a synchronization process. In this example, we have a native mobile app on a small screen phone. This app can download content to the device while the technician, for use by the technician while he is offline. In this case, the area to put the content that's downloaded to the device for offline is called My Rulebook. This same app also captures technicians' interactions, like notes and acknowledgements. In this case, where the technician is acknowledging content updates. This is an example of a native desktop app, which enables offline access to content on larger screen, rugged laptops. This app can have multiple tabs, so behave a bit like a browser. Multiple tabs can be used for side-by-side view of nested tasks, so the technician can follow a subtask without losing their place in the main overall task. This app also has the feature of being able to pop out graphics and tables into persistent windows. This can help the technician, for example, to continue to see the pinouts on electrical wiring while moving through the rest of the task. These types of mobile and desktop apps will synchronize with the content server as the technician moves between online and offline, updating any content from the server that has been downloaded to the device for offline use, and saving any user interaction, those acknowledgement, clicks, feedback, etc., the technician made while working offline. So another important aspect is, do technicians need to use both hands while working, or do they need good mobility to move around large machines? Perhaps in this case, an augmented reality device like Microsoft HoloLens, which leaves both hands free for working on the task, is appropriate. Content within the device can be driven by pointing, voice, or eye tracking, and the display follows the technician as they move around. The dashed laser pointer line means the technician doesn't actually have to touch the UI button, as the buttons may actually be out of reach. These devices help increase efficiency and reduce error rates by reducing the time from intent, i.e. reading the content on the screen, to action, actually doing the task. So there is no back and forth or forgetting what you have just read. Boeing claim a 20% improvement in efficiency for technicians working on wiring harnesses by being able to see the wiring schematics as they perform the task. Previous drawbacks of wearable devices include things like the battery size, screen size, and weight, and these have been largely overcome with these types of devices, especially Microsoft HoloLens 2, the latest type devices, giving very high levels of mobility. And it is important to note that you don't need costly virtual reality overlays that, for example, sense what you're looking at to successfully utilize these devices in your delivery environment. As long as your content is well structured, these devices can be easily included in your delivery. And that's not playing down the usefulness of 3D models and virtual reality overlays, but they are expensive and in many scenarios overkill. So in conclusion, all of the capabilities we have covered here are achievable using open standards and standards-based tools. Tools that capitalize on content enrichment capabilities that RWS provide with taxonomy, Tridion docs, and DITA. Congility also provides these capabilities for delivery with Congility Content Server. Congility Content Server can take content from Tridion docs in DITA format and deliver it for use to the right person at the right time on the right device. This is possible through leveraging taxonomy and metadata within the content and integration with other core IT systems. The delivery platform is working directly with Tridion docs and the authentication server and via middleware to other core applications like ERP or MMS, maintenance management systems, PLM, product lifecycle management systems, change management systems, and etc., to pick up metadata and attributes and log changes. The environment is a single content delivery platform, delivering to multiple channels like web portal, mobile, offline devices, augmented reality or mixed reality devices like the Microsoft HoloLens. And other destinations for the content can be web CMS, CRM, or even content as a service type integrations. So we're at the end of this session. I think I've gone quite fast and gone way ahead of the time. So I apologize for that, but I'd like to thank you for your time. I hope you found it informative. I hope you found the session informative. And I think we're open to any questions you may have. Okay, so it doesn't look like we have any questions currently. So again, I'd like to thank everybody for attending the session. I hope you found it useful, and I hope you enjoy the rest of the conference. Thank you very much.